Hi everyone, I'm going to start topic 4, which is graphing basics. At the beginning, I would like to talk about two-dimension uh, graphing system and or rectangular coordinate system, Cartesian coordinate system, which are all the same. When we wanted to visualize numbers, just one dimension, we used number line. Okay, so to visualize just numbers on one dimension, we had number line. So we had just one line, the same as here. Okay, and that was just one number line. We showed all the numbers on it. 0 was in the middle, 0 is origin, and then when we go to right, it's positive. When we go to left, negative. And I told you, if you use, for example, you use 2 centimeters to show one unit, you have to continue to do the same thing, and we call that scaling. Okay, so the same thing for the whole number line. To visualize numbers in 2 dimension, in order to do 2 dimension, we need Cartesian coordinate or rectangular coordinate system. How do we make it? We have one number line. We make another number line just perpendicular to that number line. So one of them is from left to right, and one of them is from top to bottom, or just like north to south, for example. They should have 90-degree when you just consider these 2 lines. The angle between them and also it must be 90 degrees. So we call this is perpendicular. Okay, these 2 lines are perpendicular to each other. Okay, so 0 is in the middle, and that's x0 and y0 for both of them. What do I mean by x and y? I have this one x-axis, and I have this one as y-axis. Okay, usually we do that. Okay, when I show this and this, means they continue, so it goes to infinity from right and minus infinity from left. It continues. Okay, so it doesn't stop. Also here I have this and this, so means it continues to infinity from top and to minus infinity to the bottom. I have 0 and 0 in the middle, which is x equals 0 and y equals 0. When I go to right, it's positive x, that's negative x. Here positive y, and that's negative y. These 2 lines make the paper or the graphing paper to have 4 parts. I call them quadrant, okay, because it's divided to 4 parts, and quad is related to 4. Okay, so this is called quadrant 1, this is called quadrant 2, this is called quadrant 3, and this is called quadrant 4. So we go this way. That's just agreement. We go this way. We start from here in this area, and then we go this way when we want to count. How do I show a point there? We label points using ordered pairs. So we show the point like x and y. X is the distance you have from just 0 but on horizontal. Y is the distance you have from 0 but vertical. What do I mean here? If I have P, for example, 3 and 2, in order to find the point, I should do this. I have to I have to find 3 which is positive on x-axis. Okay, for positive I go to right. So I find x-axis, this is x-axis, the yellow one, and because it's positive 3, I find this 1, 2, 3. So it depends on the scale. Maybe, so here I have 1 by 1. Maybe somewhere I say, okay, I have a space, so I want to have 2 squares, for example, 2 parts equal 1. So for example, I want to say this is 1, this is 2, for example. But if I do that, I have to continue the same way for the whole axis. Then I find 2 on y-axis. Again, positive 2, so I go up. If I have negative, I go down. Okay, so this is positive 2. Then I make a perpendicular line here, I make a perpendicular line here, and the point which I find is P, which is 3 and 2. Okay? Sometimes I see a student make mistake. For example, they point here and they say this is the point. No, this is just y coordinate of the point. They say this is the point. No, this is just x coordinate of the point. But the point is on the graph in quadrant 1. Okay, because both parts are positive. X coordinate and y coordinate, both of them are positive. So I find x on x-axis, I find y on y-axis. If it is positive x, I go to right. If it's negative, I go to left of the origin, which is 0 and 0. This is origin here, 0 and 0. Okay, and for y, I go up if positive, I go down if negative, and then I find the points by using 2 perpendicular line from this here, see, from this here and from this here, and then I have the point. When I find x and y, I make these 2 lines, and then where they touch each other is just the point. In order to do practice, I have some points here, and I want you to tell me what are those. So here I gave you the point, and I was supposed to find the point there, and here I have the point, and I am supposed to tell what is the coordinate. Okay, the point, this one is A, for example. Okay, I see A is on the origin, so A is 0 and 0. No question. How about B? Okay, I see B. I need to make a perpendicular line to x-axis and find these points. Okay, I look at my x-axis. I need to see what number is that. So I need to have a scale. I cannot say, okay, I just show you these numbers. Sorry, I just show you these parts and I don't see any number. If I don't see any number, I really don't know what's that. So it doesn't mean if I see number 1, number 2, number 3, number 4, number 5, it's exactly 5. Maybe I go 2 by 2. Maybe I say, okay, 0, 1, 2, and 3, and then that's 2.5. Okay, here I see it is 5. Okay, so I write 5. Then I make another perpendicular on a line on y-axis. Remember, must be perpendicular. Okay, straight. Okay, so that's 5 as well. How about C? The same. I make perpendicular line to x-axis first, and that's by agreement. X comes first, horizontal comes first, vertical comes next. Okay, so this one next. Okay, so it's -7 and 3. How about next? Okay, so I make perpendicular line here, and I do here, so it's -4 and -6. How about E? E is on x-axis. Okay, so it's on x-axis, but still it has distance from 0. So it is 7. Okay, 7. And how about for y? Okay, I make a perpendicular line just to y, and I see on y I reach to 0. Okay, so when I am on x-axis, y is 0. Then I can accept that. When I am on y-axis, then x is 0, because when I am there, so I make a perpendicular line to just x-axis, and I see I reach to 0. Okay. The last but not least is f. Okay, so which is 4 and -6. Remember, always horizontal first, vertical next. Okay. Now I want you to find these 3 points, 3 and -9. Okay, 3 and -9. So I go to 3, I find 3 here. Okay, and I find -9 here. Oh, sorry, it's here. And then I make a perpendicular line. So this is G. Okay. How about next? 4 and 8. Okay, I find 4 on x-axis, I find 8 on y-axis, and then I make a perpendicular line H. The last one is -5.5 -2. Okay, so that's -5, and this is -5.5. Okay, so that's in the middle. Okay, I find -5, I find -6, that's in the middle. -5.5 and -2. So I find this here, and then I make this line and this line, and that's I. Okay, so now we can say each point is on which quadrant. Okay, point G. Point G, I have x positive and I have y negative. Okay, even if I picture it in my head, I can see if x is positive is right, if y is negative is down, so I am in quadrant 4. How about H? Both of them are positive, so I am in quadrant 1, because x right and y up. How about the last one? Both of them are negative. Both of them are negative means one of them left, one of them down, so it's quadrant 3. Okay, so still here I can just make a rule for myself. If I see both of them positive, quadrant 1. If I have both of them negative, it's quadrant 3, because both of them are negative. Quadrant 3. If I have one of them positive, one of them negative, maybe quadrant 1 or 2. It depends on which one positive, which one negative. But still, I don't recommend to memorize. I really don't want you to memorize. I want you to learn and to try to picture it in your head if I ask this question. Okay? So, just in order to summarize what we said about rectangular coordinate system or two-dimensional coordinate system, I would say, in order to visualize one number, just I use one number line. When I want to show two dimension, I use two number lines, one of them horizontal, one of them vertical. They are perpendicular to each other, means the angle between them is 90 degrees. It makes the paper to 4 parts, so I start from here, and I find, okay, I say 1, and then I say 2, and then I say 3, and then I say 4. Okay? In order to show a point, I have a pair. The first pair is on x-axis, the second pair is on y-axis. I find on x, positive right, negative left. Then I find on y, positive up, negative down. Then I make a perpendicular line, and then I find the point. If I give you the point, you can find. If I give you the numbers, you can find the point. If I give you the point, you can give me what is the coordinate of x and y. Okay, so these are all here as a practice. Now, I want to know if I have an equation, how can I graph it? First of all, I can say a mathematical equation is when you have two mathematical expressions they are just equal. Okay, so I have a math expression here, a math expression here, and I have equal between them. When I want to graph it, look at this. I have y equal 2x minus 1. Or maybe I have, for example, w equal 2z minus 1, for example, okay? Usually we use x and y. Independent variables are on x-axis. Variables that are there no matter what, okay? So variables you choose just whatever you want. They are independent variables. Okay, we plot them on x-axis. Okay, so independent are on x-axis and horizontal axis. Dependent variables, however, they have to be on y-axis. What do I mean by dependent variable? Look at here. Here I can choose x equal 2. But I cannot say y is equal 10 because I like it. No, y is 2 multiple 2 minus 1, which is 3. Then I can say, okay, how about if x is 0, then y is 2 multiple 0 minus 1, which is minus 1. Okay, so I have 1.2 and 3, I have 1.0 and minus 1, and both of them are satisfying this equation. So both of them are on the line or on the graph of this equation. Okay, dependent variables that they are found using x are on y-axis. So I can choose whatever I want for x, but y is just found using those points. So I cannot say y is 10 because I like it. No, y is made by the equation. Okay, so now I see this graphing paper. Nothing is on it. Okay, and I want to graph my graph y equal 2x minus 1. I want to do it. Okay, so I give some values to x and I find y. This is called table of values. Okay, this is called table of values when I give some values to x and I find y. Okay, this method can be used for any equation, for any function, for any graph that you want to just graph it. So you can use table of values. You give some values to independent variable, and then you find the dependent variable, and then you find those points on the graph. Okay, so you found those points. For example, you have like this. So we will do this later in example. So you have x, you have y, you give some values here. You found these values dependent to those values, and then you want to graph it. By agreement, when I want to graph it, I have to make two perpendicular lines. One of them left to right, one of them up down. Okay, so I do this. Depends on my values. Maybe I see x has positive, has negative, so I show positive x and I show negative x. Maybe I see y has positive and negative, so I show positive y and negative y. Maybe I see no, I don't have any negative y, so I don't need to occupy a part of my graph for negative y. This means graphing techniques. Okay, so you are using graphing technique to show your graph very beautiful, to use your graphing paper in a very good manner, to just use the maximum part of it for your graph. Okay, so it depends. If I see positive, if I see negative for both of them, so yes, I make it to just I divide my I divide my graphing paper to 4 parts because I need all of them. Independent variables goes here. Independent. Dependent variable here. Dependent values here. Okay, so these are values that you choose. These are values that are found using the equation. Okay, you just substitute those values and you determine dependent variables. In the lab, when you are working in lab, for example, these values can be, for example, x can be time, for example, or lambda, or so a parameter that you use for measurement. Okay, so a parameter, so maybe I can type it here. Okay, so I can do it here, maybe, yeah. Okay, so parameter used for measurement, so it goes here, for example, maybe lambda, maybe time. Okay, so what you measured in the lab goes here. So what is measured in the lab, so for example, you use lambda, you use time, and you measure something that you measure, something you find, and they are dependent to these values on x-axis. Okay, so they go on y. So here I can write what is measured yeah. Okay, so as I said, any equation can be graphed using a table of value. Okay, so what do I mean by that? So you give some values to x, which is independent, and you find y. Y cannot be whatever you want. Y must be just found using the equation that you have. Here, in order to be the same, for example, I give these values for x because we can choose anything we want, so we want to choose this. And usually, agreement, when I want to graph a line, I use these values for x. Okay, these are important values that we use for x when we want to graph a line. How do I know I have a line? When I have just two variables and both of them they have power 1, and I don't see any term with, for example, x multiple y, then it means I have a line. Look at this. I have y power 1 equal a x power 1 plus b, and I don't see any xy, any x multiple y, because if I see x multiple y, then it means I have a term with degree 2. Here I say this is a math expression, and this one has one term and this one has two terms, and each term has degree 1 because each term has power 1. If I say xy, it's power 1 for x and power 1 for y, and that's 2 because I multiply them. Okay? This is degree 1. So when I see y and x, and when I see y power 1, I just see power 1 for x. For x, I just see power 1 for y. That's a line. That's a linear. That's a linear equation. Okay? That's why I call it degree 1. Okay? But if I see something, for example, I can show it maybe here. If I see, for example, so y plus xy equal x plus 5, something like that, then here, for example, degree of this is 1, degree of this is 2, because I have 1 and 1. Okay, so 1 and 1, so it will be 2. Degree of this is 1 as well. Okay, so that's not a line, that's a curve. Okay, so if I see just degree of each term is just 1 and I just have 2 terms, it means I have a line. This is a linear. Okay, so here I have a line. Yes, of course. So if I want to use table of values agreement, I use these values for x. -2, -1, 0, 1 and 2. Okay, and I go from small to large. Okay, what is y if I use -2? Y is not whatever I want. I have to find it. So it's 2 multiple -2 -1, which is -5. It's 2 multiple -1 -1, which is -3. It's 2 multiple 0 -1, which is -1. It's 2 multiple 1 -1, which is 1. It's 2 multiple 2 -1, which is 3. Okay. So now I want to graph it. What do I see for x? For x I see negative and I see positive. What do I see for y? For y I see negative and I see positive. But one of them has more values. One of them goes to 5, -5, one of them just to 3. Okay, so I can graph it this way. I need positive x and y. I need positive and negative on x. I need positive and negative on y. But for negative y, I need a little bit more. Okay? So here I can, okay, so for negative I need a little bit more, so I can do this. Okay. Do I have negative and positive on x? Yes. Do I have negative and positive on y? Yes. More negative on y? Yes, a little bit. Okay. So 0, 1 and 2. I can say this is 0, this is 1, this is 2. Yes, I can. But then I didn't use the whole part of the paper. See, I can say -1 and I can say -2. Yes, I know, but then I am using just a very small part and I don't want that. I want to show my graph very beautiful. I want to use the whole part of the paper as much as it's possible. Okay, so I do 0, I do 1, even 4, and can I do the other side? No, the other side I can't. So it is 1, I have to check both sides. It is 2. Here is -1 and here is -2. Remember, I am doing 3 by 3. I have to do 3 by 3 for the whole part. Okay? So, for x-axis, I do 3 by 3. 3 squares by 3 squares. So it means 3 squares is 1 unit. Why? Because I have a space. And I just need to 2 and 2 minus 2. How about the other one? Okay, the other one. Okay, so how about the other one? Let me see. I need 1, 2, 3. So can I do 2 by 2? So it's 1, 2, 3, and the other one -1, -2, -3, -4. No, I don't have a space for -5. Okay, so I just do 1 by 1. So here I do 1 by 1. Okay, so 1, 2. So it's 1, 2, 3 here, and it's -1, -2. So it is -1. Oh, sorry. That's -2, and that's -4, and that's -5. Okay? See, I try my best, okay? And I cannot do more than this because I don't have a space to go 2 by 2 for y. But for x, I have a space to go even 3 by 3. So I do it. So I give values to x. The values to x by agreement are from -2 to 2 when I have a line. I find y values. I see I have negative and positive on both of them. For one of them, I have more negative. So I have to give a little bit of more parts for negative. But then I look. If I go 1 by 1, it will be very small for x. So I don't want. I want to use my whole paper as much as it's possible. So I do 3 by 3 because I have a space. For y values, even I cannot do 2 by 2 because I don't have a space for -5 then. Okay, so now I find my points. -2 and -5. So one of my points is -2, -5. Okay, so -2 is here and -5 is here. This is the point. One of the point is -1 and -3. So -1 and -3 is here. One of the point is 0 and -1. So 0 and -1, which is here. One of the point is 0 and 1. 0 and 1. So, oh, sorry, 1 and 1. So 1 and 1 is here. And one of them is 2 and 3 is here. So 2 and 3 here. Okay? Now I'll connect them. And it continues because if I continue on x-axis, if I continue on y-axis, so of course it continues. Okay, I have more values. Okay? If I connect them and I see I don't have a line, for example, I do this and then I have to do this and then I have to do this, means I made a mistake. I have to check my points. Okay? So I stop here, and for this, the next graph, which is not a line, this is a curve, because I see power 2 for x, I continue after. Thank you. Bye.